Okay, we're in section 11 of the notes here, and it's, like this goes section by section up to 139 with some additional material and appendices. But right now we're at section 11. Again, as you're taking steps. You'll get to the 139th step, but I'll be honest with you, the higher you go in in these section numbers, the more difficult it becomes. But in the beginning, it's really not so bad. It's really just a domain of beginning algebra. And, certainly I'd say algebra is sort of almost a study of patterns in some respect, and Wells is big on using patterns. All right, so let me just do a few reminders here. My name is Ron Bannon. This is a draft version. It's a draft version of a course designed by Webster Wells back in 1904, and it was an advanced algebra course. All right, each section pretty much looks the same. There'll be contents, there'll be examples, there'll be exercises. These short videos that I present to you are basically just simply giving you some talk through on the examples that Wells presents. All right, they may look different in the way Wells does it, but it can't hurt to see someone do things. If you need to reach out to me, my name is Bannon. My email address also looks like Bannon, with the exception that the A symbol is replaced with the @ symbol. So it's BNNON, and I live in the United States. That's my email address. All right? So I'm going to just scroll here, and what I want to do is just talk about the pattern that Wells is presenting here. And the pattern he's presenting here is the square of this thing. And he claims that it's this over here, and you should be able to easily verify that. All right? He's claiming that this is A plus B plus C squared. All right? So what I want to do is I just want to go through that with you, and I'm going to multiply it out. All right? So A plus B plus C squared. And what's that going to give you? A plus B plus C. A plus B plus C. This will give you A squared. I'm distributing the A across three terms. Plus AB plus AC. That distribution's done. Now we're going to do B. That's going to give me AB. And that's going to give me BC. That's going to give me B squared. I'll put that over here. And did I do that right? Let's see. AB, B squared, and BC. Yeah, I did it right. Let's do the next one. Next one's going to be C. So that's going to be AC. And you're going to get BC. And you get C squared. What does that give you? A squared plus B squared plus C squared. I'm going to write a little differently than Wells does. I'm going to say there's two of everything now. There's two of these, and two of these. So I'll write down as AB plus AC plus BC. Is it the same thing that Wells presents? It is. All right. Now, certainly, you notice what I'm writing in the notes. It looks kind of scratchy looking to me. It's just my penmanship, I guess. And this is why things really need to be typed up at some point. Now, he really doesn't say much in this section. He says this is it. I mean, this is the totality of his section over here. And then, of course, what he does, he gives you an example. And what I want to do, I want to go through it with you. All right? So I'm looking at this thing, and I'm going to say, hey, it's probably A squared plus B squared plus C squared. Right? I'm just imagining it's something like this. Plus 2AB plus 2AC plus 2BC. Now, by the way, things could get jumbled, and you may not see it, but I'm glad at least he put the squares up front. All right? And then these things, which, looks like a combination of the XY, XZ, and YZ. So for some students, it's just a guessing game what it is. They don't see it. So I'm gonna do a guessing game. I'm gonna say it looks like A is 3X. I'm going to say B looks like it's Y, because B squared would be Y squared, right? And C looks like it's going to be 2Z. Again, what am I doing? The first three terms is A squared plus B squared plus C squared. That would certainly work out. And then what's the next term? Is twice AB. So I'll write that down. The next term would be twice AB. I got troubles immediately because I'm not getting the minus 6XY. And I'll tell you why that is. I would get 6XY. So what I'm going to do, I'll make a stab at it. I'll say this over here. Right? Let's take a look, see if that works out. And would you get the first term? If I squared that, you get 9x squared. Yeah, things look like they're great in the first three terms. Would I get the 2AB? Would that be minus 6XY? Well, let's take a look. Yeah, minus 6XY. And let's put the next one down. What's going to be? 2AC now. And I'm adding them on, okay? I'm hoping it's going to be minus 12xz. And what do you get? Well, 2 times 2 is 4 times 3. Yeah, minus 12. And you get xz. That worked out beautifully. Let's see if we get the last one, which is 2bc, right? I'm just checking. And we'll do a further check later. So 2bc, what would that be? 2bc. That would be 4yz. That also works out. So I'm going to claim, by me doing this sort of like looking at and looking for that pattern that he says, that this 9, I'll write this down for you, this 9x squared plus y squared plus 4z squared minus 6xy. I'm not going to look at the answer key yet. I'm just doing my work, and I would recommend you do that too. So I'm going to claim it's this thing over here, which is minus 3x plus y plus 2z quantity squared. I would claim that's my answer now. Now, certainly, if this is something where you don't have an answer key, you could easily check that. I'm going to go through the check for you, and I'll talk about some variations in the answer as well. Squaring it, I'll put this down. And I'll go through squaring it now. So minus 3x on minus 3x is 9x squared. And then I would get minus 3xy. And then I would get minus 6xz. That's done. Then what do you get? Minus 3xy. All right, I'm just doing the second term now. Y squared. And let's see, what do I get there? I get 2yz, right? All right, that one's done. Let's do the 2z now. What do you get? Minus 6xz plus 2yz. I like to put things in alphabetical order, by the way. And then I get plus 4z squared. I'll add them all together. And what does it give me? 9x squared plus y squared plus 4z squared. And then what I get minus 6xy minus 12xz plus 4yz. And am I getting what they said I should get? Yep. Yes, 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 and yes. So that's a good looking answer. All right, so I'm going to say other things you could do is you could jumble this around if you want. You could write this as, maybe y plus 2z minus 3x. That's a commutative property of addition when I'm doing that. And there's other combinations you can put down over here. But, certainly if you're looking at an answer key, you might be a little concerned about another answer that's listed. And what I'm going to do is I'm going to say that, I'll write this on the side for you, minus 3x plus y plus 2z. I could also write this way, minus 1 times 3x minus y minus 2z, and then I'll square it. And what's interesting about this over here, if you square the minus 1, you get 1. So this really turns out to be the same thing as 3x minus y minus 2z quantity squared. This answer is also being listed for you, all right? So I'm also going to say it's, you may recognize other patterns over here, and certainly I think it's important to do that. You may recognize perfect squares. It is a perfect square. It's absolutely a perfect square. And they're going through a little different method over here, but nonetheless it's still a perfect square problem, all right? And that takes also some effort to recognize that as well. So the deal about this one over here, you got to start moving forward, and the forward part for you guys is understanding what's been presented to you. Very short section of the notes, very short amount of material. But you start doing the exercises, one problem after another. Now, when I do the exercises, I do some work. I might write things a little bit differently. I like to use uppercase letters for patterns, but that doesn't mean you want to use uppercase letters for patterns. It's just me. For this one, I'd have to do it because they're using lowercase letters, and you may not recognize the patterns. All right? Same thing for the other problems that are being presented to you. I use uppercase for the patterns. Again, they're asking for this uppercase. Do not believe you need that pattern after it, though. You could go back and probably say, gee, I'll try something else. I'll try a different method. And that's fine. It really is fine. When I write answers in my key, though, I tend to write answers down for variance. What do you mean by that? Equivalent answers that may look different to you, but they're identical answers, right? So answers that may look different to you, but they're identical. How am I doing that? Let me just remind you what I'm doing over here. Like if I looked at this one here, I could factor out a -1. I'll put this down for you. And if I factor out a -1 from this, what would you get? Let me write this down carefully. You would get 5m minus 6n minus 1, and then that would be quantity squared. You know, -1 squared is just that. It's 1. And what are you left off with? 5m minus 6n minus 1 quantity squared. That's why I'm saying these two answers are really the same answer. It may look strange to you, but they're the same answer. All right? They're the same answer. All right? This often trips students up when they look at an answer key that doesn't have multiple answers down. They wonder why they didn't get their answer. Sometimes they do spiffy tricks. All right? So keep that in mind. Thank you for your attention, and please do consider reaching out to me if you feel the need to do so. Thank you.